my name is Daria, and I'm a developer relations engineer at Neon. And today I'll show you how you can connect to Solana using Neon. So first, let's go into what Neon is. We are a Ethereum virtual machine on Solana. So what that means for you as a developer is that you can take your existing Solidity code and just go ahead and deploy it with us. And then you can interact with your project using your favorite Ethereum tooling, and specifically MetaMask wallet or any other EVM compatible wallet. So because we are running on Solana, we kind of combine the best of both worlds. So we have all of the benefits of Ethereum, so you don't have to change your code. You can use Viper or Solidity. You can use all of the well-known Ethereum tooling like MetaMask, Hardhat, DevRel, Remix, also anything ZK related. You can use the Ethereum RPC API, and then also Ethereum accounts, signatures, and token standards like ERC 721 or ERC 20. And then we also bring in Solana benefits. Transactions on Neon are executed in parallel. We have low gas fees, high transaction speed, access to growing Solana ecosystem and liquidity, and also we use Solana consensus mechanism without any additional infrastructure or need for a sequencer. So we have been live on Solana since July 2023, and this is the overview of our tooling. So we have the EVM, the proxy server that acts kind of like an API. We have a tracer API for debugging. We have Neon Pass for sending tokens from Solana to Neon, and then we have the Neon Faucet for developers, and Neon DAO, which is the owner of the Neon EVM program. And the gas fees are extremely low, and we also achieve transaction speed of around 2,000 transactions per second. And this is Neon ecosystem. So as you can see, we have all of the standard EVM wallets available. So MetaMask, Trust Wallet, Wallet Connect. We use the same RPC providers as Ethereum. So P2P and Everstake. We have two explorers, Block Scout and Neon Scan. We support indexers like the Graph and Subsquid. We have NFT tooling, bridges, multi-sigs, and most importantly, we support all of the dev frameworks that EVM developers use. So Hardhat, Foundry, development platforms like ThirdWeb, and also Remix ID. And this is the overview of the dev tooling specifically. So as you can see, we support all of the Ethereum-specific tooling, also JavaScript libraries, OpenZeppelin standard, and so on. So this is the overview of Neon architecture. We have first, the user who interacts with Neon through a wallet. It can be Solana or EVM wallet. For example, MetaMask. MetaMask sends a transaction to a dev frontend, and then this dev frontend forwards it towards our proxy that acts like an RPC. And after that, the RPC forwards the Solana transaction to Neon EVM program on Solana, where the bytecode is translated into Solana instructions and subsequently executed on Solana. So this is the classic structure of a Solana program. You can see that it is different from Ethereum. It stores data in a different way. So you have separate accounts for your main account, then you have program-derived accounts, and you also have token accounts. So your tokens each have separate account. And now I'll show you how Neon uses this to support EVM. So this is the Neon EVM program. And as you can see, we use the free space that is allocated for data in the accounts to store some of the EVM information. So Solana allows up to 10 gigabytes, or megabytes, sorry. Solana allows up to 10 megabytes of storage, and Neon uses about 2. So in this way, we are able to put EVM bytecode, Ether address, nonce, balance, and all of the other relevant information into an account and then use it to execute the transaction. So this is how a Neon transaction is packed into Solana transaction program. We have an account list, and we utilize it to store a list of Neon accounts. Then in the program index, we store the index of Neon EVM program. And then in the data field, we store all of the Ethereum-like transaction data, like nonce, gas price, gas limit, value, and data. This is a diagram of how parallel execution works on Neon and Solana. So because of how Solana manages data and how it separates accounts and programs due to C-level execution, we can run parallel transactions also on Solana. So this is how we achieve the speed of up to 2,000 transactions per second. And another exciting feature is composability. So composability is the ability to use Neon EVM and call Solana transactions through your Solidity code. So this is an example of how it works. You have your Neon EVM account, which is represented through your, for example, MetaMask or any other wallet, and then you send an EVM transaction to a call Solana contract, which is an interface for a precompile inside of Neon EVM. So you call the execute function, and you can think about it similar. You can think about it kind of like a delegate call, where you pack your instruction, name of the function, and parameters that you want to execute, and gets forwarded to the precompile inside of Neon EVM program, and then forwarded to any Solana program that was marked as a destination in this execute function. And this is actually, I'm going to show you, and then it has functions like get resource address or get Neon address that can restore relevant information from Solana, and mainly the execute function, which you can use to call a specific instruction in any program on Solana. So this is a diagram of how transferring tokens from one account to another works on Neon. So in this case, we are transferring USDC coins using composability. So we own a Neon EVM account, and then we directly call Solana through the composability feature to send some tokens to Solana account. So you can see that we prepare an EVM transaction where we mark token program at the destination, and we want to call the transfer function. And we have a destination token, signer, source, and amount inputs. It goes to Solana precompile inside the EVM program, and then to Solana token program that owns the token program for USDC, and then they both handle the transfer from one token associated account to another. And I also wanted to show you one of the composability transactions. So this was a transaction sending some Solana from one Neon account to a Solana account using composability feature. So we can go into Neon Scan on our block explorer, and we will see that one transaction on Neon corresponds to two transactions on Solana in this case, and we can go ahead and open it, and we'll see that it was actually doing the sending, so it sent one sol from the account that Neon account owns to the destination account, all through just using Solidity code, and this is how it works. So you can use Hardhat and Web3.js to do this. You need to set up your transaction, get some information like public key, sender account, receiver account, and then you can just call the Solana instruction through Web3.js. And so in this hackathon, we have two tracks, and one of them is focused on composability feature. So the one that I talked about, so if you call Solana through Neon interface, you will qualify for this one, and another one is more meme coin and degen toolbox focused. So for this one, you don't need to directly interact with Solana through Neon. You can just use Neon EVM and deploy on it. And lastly, we have a little overview of how bridging and works from another EVML2 to Neon, and how bridging works, not bridging, but communication works between Neon EVM to Solana. So for example, if you're bridging tokens from Ethereum or Polygon, you have to use a bridge, which is debridge in this case. And if you're sending tokens from Neon EVM to Solana, you can just use our Neon Pass, which essentially wraps tokens from Solana to be compatible with Neon, and then when you send them back, it kind of works vice versa. And then if you're building on Neon, you can join our developer resources. We also have GitHub, where you can see all of the examples of our code. If you want to go for one of our bounties in the hackathon, yeah, thank you for coming.
Thank you. Sorry, I was a little bit late, so I didn't see the contract for the Solana call. So there was the metadata, and I think, yeah, account meta. That's the account information from Solana?
Yeah, this is the, so on Neon, you as a user, you interact with your EVM account, but obviously the Neon program handles the creation of a corresponding Solana account that you own for you. And then when you use composability, you have to use the struct where you essentially pass some Solana account information, especially if you're sending, for example, some SPL or SOL tokens from EVM account on Neon to another account on Solana specifically. So this is what it is for.
Okay, so, and again, I was late, but obviously you guys have this abstraction of paying the Solana gas using Neon, right? Or should I have some SOL on my account in Solana to pay for the gas?
So since Neon EVM is not an L2, and each of your transactions actually executes on Solana, you pay for gas in Neon, but the Neon EVM program handles the gas payment on Solana, so you do essentially pay for it. And actually, it is the same thing when you deploy a contract on Solana. Because of how the account model and rent works, it costs you kind of a little bit more, because we want you to pay for 2 years rent, so that your account is yours forever. You don't have to pay rent for it.
Oh, okay, perfect. Thank you.